In this demonstration, you'll learn how to generate contacts using 3 different methods. The first 2 are automatic, using a template or the interface generator. The third method is to manually set up contacts and modify contact properties. I'll start by selecting a simulation template from the study panel. I'm going to select the structural template, and then select a static analysis. On the options list, I can specify if I want connections in the interface of the bodies detected automatically using default settings. I'll select this option so that contacts are generated as part of the template process. I'll select the file for this crank assembly. AIM loads the geometry and sets up a simulation process with typical default settings for geometry, mesh, physics, and results. In the physics solution task, you can see that AIM automatically generated 2 connections for this case. Let's take a look at these connections. This first contact is between the crank and the bar at 2 faces each. I'll hide this body so you can see the contact more clearly. At the bottom, you can see that AIM has also generated a set of behavioral properties for the generated contacts. Now I'll select the second connection from the navigation bar. You can see that this connection is between the bar and the crankshaft at 3 faces each. Next, I'm going to show you how to automatically generate connections yourself if you aren't using a template. I'm now at the same point in my process as I was earlier, but because I didn't use a template, no contacts were automatically generated. Instead, I'm going to use the interface generator to generate contacts for the model. To begin, I'll add an interface generator from this Add menu. By default, AIM generates contacts for the physics region, which is the whole model in this case. I can also select specific bodies for the location. AIM automatically suggests a default tolerance, but you can also set this tolerance to a specific value. AIM generates a contact between 2 or more faces when the distance between them is within this tolerance. By default, the interface generator creates 1 set of behavioral properties that will be used by all generated contacts. If you intend to customize the behavioral properties of individual contact pairs, you can also direct the interface generator to create an individual set of behavioral properties for each generated connection. When I click Generate Interfaces, AIM automatically generates contacts for the model using the default tolerance. AIM also automatically generates an associated contact behavior. You can see the generated interfaces here. Because I'm using the same crank assembly, AIM generated the same 2 contacts it did when I used the template. And both connections are using the same set of behavioral properties. When you delete the interface generator, it removes the interface generator and all connections and connection behaviors generated by it. I've been taking advantage of AIM's powerful automatic contact generation feature. However, I can also create contacts manually. To begin, I'll add a connection from this Add menu. I need to set the locations for the contact between the crank and the bar. I'll select these 2 faces and add them to location 1. Then I'll select these 2 faces for my second location. I'll select a new contact behavior. If I'd already created a contact behavior, I could select it here. Each connection behavior is automatically created using defaults. You can change these defaults to customize your contacts. For example, you can change the contact type from bonded to new separation. Additional behavioral properties are available if you click this filter icon. Now I'll create the second contact. I've set the locations to the faces of the crankshaft. I'd like to use the same set of connection behaviors I specified for the previous contact. So instead of adding a new connection behavior, I'll select the connection behavior I just created. Connection behaviors are designed to be independent of a specific connection, so you can apply them to multiple connections as needed for your physics solution. This concludes this demonstration of the 3 methods for generating contacts.